Good morning, guys. Welcome to another episode of Xa Talk Show. We are going to talk about some programming idioms or programming languages and the relations of programming language and its machine. So let's go to my computer blog. Let's see if I'm live. Yes, I'm live. That's good. Okay, computer. So I want to talk about why array access why is array access constant time. Now this is a very interesting aspect. When you have a array, for example, this if you've been programming for a while, you know that when you have, for example, my array and you want to access it, let's say you want let's say var x equals to, you want to take the 99th element. Now compare this to a list. Uh, Typically programming, they will teach you in computer science classes or programming classes. They'll say that array access is constant time, random access, meaning that you can access any element in an array. And the time it takes is small. It's constant. Doesn't matter which element, like 99th or 10 millionth array element. Okay. However, this is different from the other data structure called list, or typically called linked list. If you access a linked list, if you access the 99th element, it will take, the further back the element you want, it will take longer to access it. So array access time, it has constant random access time. But why is that? You wonder why is that? Because let's see how many people are watching. Two. Say something, guys. Uh, okay, let me modify the date. So you wonder why is that? Let me hold on a second. Let me modify the date. Xa Talk Show. Uh, okay. So you wonder why is that? First of all, let me tell you what is a programming language and what is programming language, what is a machine for the programming language. Well, before I say that, just wonder like why is array access time has constant random access time. I have tried to learn this. I struggled to learn this for like 10 years, most of the 2000s. Uh, you know, so not until 2010 or so, I start to understand. You see, what this come to, I mean, the why is this puzzling is that, you know a programming language is basically a programming source code is pretty much a recipe. Okay, recipe like cooking. It's basically step by step instructions. That's what algorithm means. Now now step by step instructions, you have to write down the instructions, using some language. For example, English. When you are cooking, English is your language. You put eggs, you break the eggs, you mix in flour, you mix in water. That's instructions. And instructions, the written instruction must be in some language. So you have a language, English, for cooking. But for programming, that is programming languages. And the source code, basically the recipe book, or the source code, your program, that is the recipe, that is the algorithm. So you have two things here. You have algorithm, which is step-by-step instructions, and you have a programming language, which is the language that these instructions are written in. You need that because For example, to communicate, you speak English or speak Chinese or Russian and so on. So you have algorithms, which are instructions. You have recipes. I mean, programming language to write down your recipe, your algorithm. Then you also need another thing. That thing is the machine you are operating on. For example, when you are cooking, mm, when you are cooking, you see, when you are cooking, you are doing with things. You take eggs, you take water, you place the eggs in this bowl, you take the water in that cookware, and you put them on stove. Those are your equipments. I mean, those are the things you work on. Let's call them machine. Without that, it doesn't make sense because you have cooking instructions, you have recipes, but you see, you need to actually do, take your hands, take the eggs, break them, put the water here. That's the things you work on. So all these things, we in programming we call it a machine. In the same way, another way to easily understand this whole programming concept is with a abacus. You might have seen an abacus. So let's see, abacus. So abacus is one of the most primitive computing machine. So here you have an abacus. This is a Japanese style abacus. You move the beads around to different positions. And here is a oh, this is a Chinese style abacus. Chinese style abacus has two rows on top. And here is a Japanese style abacus, which only has one row on top. In Asia, in Taiwan, and when I was small, we have abacus lessons. But anyway, abacus is like a calculator. It's the earliest computer, you might say. And what does it do? But basically, abacus is just like stones on the ground. Basic, bunch of stones. You move them, you position them in different ways, and you read out. It has some meaning to you. So the easiest way to understand programming and computers is with the abacus. So with abacus, you have, first of all, you have the machine. The machine is the abacus. Good morning, Isaac. So the abacus is a machine, okay, which is like today's CPU, okay. So abacus is a machine. Then uh, you need instructions. That is, you tell it what to do. Suppose you want to add 1 plus 2. How do you do it? You move these beads here, or you push that beads there. Those are instructions. Then you need a programming language, which is a recipe. I mean, wait, hold on a second. The instructions is the algorithm, is the step by step instruction. That tells you what to do. That's the algorithm, which is your recipe. So algorithm, recipe, they are kind of the same thing. But you need a programming language, which is the language your recipe is written in. For example, for abacus, you have, for example, manuals. There are books that teaches you how to use an abacus. So that's the abacus manual. So that is basically you can think of it as a programming language. So here we covered three things: the machine you operate on, that's the abacus; the programming language, which is you can think of it as the tables in a abacus tutorial, programming language. Then you have the actual instructions, which is algorithm written down that tells you exactly how to calculate something. So machine, uh, we have machine, we have programming language, we have instructions, algorithms. Then we also have input and output. That's the essential thing. Input is like what you want to do. Input, you have certain input coming, then you have certain output. It's the input output that makes the whole thing useful, because we want to add 1 plus 3. That's the input. And what is the answer? That is the output. The output is the answer we want. So you have input, output. When you have an input, you follow the instructions, which is algorithm. Algorithm that tells you what to do. You operate it on it, and the instructions, algorithm is written in a programming language. It tells you what to do. Then you do it on the machine, which is in this case, abacus, or a bunch of stones. You move them around. Then after that, you have the output. You just read, where the positions are. Then you know the answer. Good morning, George. Also, so okay, so that's abacus. So why am I talking about this? Because abacus gives you a very clear understanding what algorithm means, what programming language means, and it also shows you the importance of a machine. You know, because there is always any algorithm, any concrete algorithm requires a machine. Because if you look at the abacus, you will know, if you just have instructions without machine, what does it mean? It does. You can, instructions is, step by step operations on a machine. So that is why it's important. Because when we program in Python, for example, Python, Lisp, or JavaScript, we forget the CPU, because today things are very complicated. You have compilers, you have machine language, you have CPU, and few people actually understand how CPU works. It's billions of transistors in electronics. But so when today's programmers, when you program Python 1 plus 2, you don't think of machine. Like, where is a machine? You just print 1 plus 2, and 3 comes out. But it when you want to understand computer science, when you dig into the details of programming languages, their programming language design, programming idioms, programming styles, the semantics of programming languages, all these things, list versus array, which we are going to talk about today. When you talk about programming, actually, it's important to realize there is always a machine behind it. Machine can be, there are all type of machines. Abacus is one machine. Today's CPU is one machine. There are so many different types. As you know, you have ARMS kind of architecture. CPU, you have Intel CPU, i5, i7, and so on. You have the AMD CPU. Then you have GPU. Gets more complicated. But anyway, all those are different machines. I mean, those are practical machines we are using. But then there's also abstract machines like Turing machine, the Turing tapes. You might have heard of, and Turing machine, cellular automata, uh, state machines, register machines. Those are kind of more abstract, or even lambda calculus. You can think of it as a machine. So so uh, so yeah. So remember, there are three things when we program. There's a machine, there's a programming language where the instruction is written in, and then there is the algorithm. Algorithm is just the actual instruction. Now, why do we need a programming language? Because you need to write it down. Like when I write a letter to you, it may be Chinese or English. It's written down, so that is why. So that is what programming languages are. Now, when you look at this way, you understand that there are different programming languages. They are actually different because it's almost like natural languages. They are different because they are different ways to express same thing, for example. So that's why there are different programming languages. And you can also see, by this, since we are looking at the whole thing in this way, you can also see, okay, so algorithms, algorithms are step-by-step instructions in a specific programming language. The language is written in, a source code where you read, and it is for specific machine. You see, all these three things are tied together. There can never be a like abstract algorithm or generic algorithm. Actually, that doesn't exist because the very nature, the very definition of an algorithm or step-by-step instruction is actually to operate, to work on things, and these operations are expressed in a programming language. So machine programming language algorithms, they are all tied together. They must be concrete. Basically they all eventually rely on a specific machine. The machine can be a Turing tape, can be CPUs. Today's CPUs, a specific CPU, or can be abstract, state machines, register machines, and so on. It's important to realize these because when you are, when you dive into programming language designs and stuff, it's important to know these. So, but today we are going to talk about array. You see, when we program, we learn that array has random, constant random access time. But why is that? Why? For example, let me try to explain why this is interesting question. Because because array is a programming language construct, so we can, let's try to put the whole array concept into the abacus, or into, let's say, let's go primitive and into a bunch of stones on the floor. Let's say we have 10 stones, okay, 10 of them. We put it on our desk, on the floor. And let's say our arm is a machine, so we can take this stone, maybe think of the stone as abacus, like we can move over here this column and push this stone up, and then move to another column, push the stone up, and so on. So what is an array? Array is a list of items that each item holds a value. Uh, but let's just think of the stones on the ground. Let's just think like the abacus. So we move our hand to here, you push something, and we move here and push another stone. So why is that? How is it possible when you have something like array 99 or array 9, for example? Somehow it's like constant time. I mean, if you think about abacus, obviously, doesn't matter which position, it's not constant time. Your hand doesn't magically disappear from here and appear there. There's a distance involved. You see. So anyway, so there are a lot of explanations on the web page or even in textbooks. They are, in my opinion, they are kind of all wrong. They don't cover the heart of the thing. Okay, let me show you. Uh, okay, why is array access time constant? Let's go to Wikipedia. Wikipedia. You think you would trust Wikipedia? Let's say what Wikipedia how does Wikipedia explain things? Okay. Uh, so let's go to Wikipedia. Array. Again, remember the thing we are trying to understand, explain. The topic is why is array has constant time random access, while list, yeah, Why is array has constant time, random access time? So let's see Wikipedia. Okay, Wikipedia is now it's like a bunch of articles now. Okay, an array is a systematic arrangement of similar objects, usually in rows and columns. Okay, that's music, science, biology, computer science. Okay, Wikipedia is getting more and more complicated. So now it has array data structure, array data type, and associative array. Okay, the one we want is array data structure. Wikipedia is actually really improving because when I dig into computer, I study these kind of things. I do realize, I do see it's actually improving incredibly in the past 20 years. Every year, because I check it every year. Um, let's see. Let's see if I'm still going. Okay, so Wikipedia, because many things I was confused. I see there's a confusion in the popular generation. After a few years, I see Wikipedia actually cover it because one of the thing I think there's a major difference confusion is array data structure versus array data type. Exactly. Now, you see, now Wikipedia has actually two articles distinct from each other. They are not the same thing because when we programmers, there's a tons of confusion. After it's not until after 10 years you actually start to see, okay, these two things they are totally different. That's why so many people or you get confused in back then. Anyway, array data structure and array data type in programming languages, they are distinct concept. But anyway, let's go to, and this is also why when you talk to programmers, like we have arguments about programming online, on Hacker News or other way, online forums, Stack Overflow. For example, Stack Overflow, there are tons of questions. Usually there are confusions. Like we say, oh, you should use an array or, you should not use an array. But actually, different people have different concept of an array because array itself have different meaning in each different languages. Like, for example, JavaScript array, it's not really a array. It's not data array data type. It's like it depends on how JavaScript is very complex. Sometimes it's actually just a hash table. JavaScript array, and you have PHP array in PHP means entirely different thing than array in PHP is kind of a mix between, again, it's a mix between hash table and array. Okay, it's kind of like hash table where the keys are numbers. Okay, same thing with JavaScript. They are actually hash table where the keys are numbers. You know, but Python array is kind of a true array. You call it smart array or extensible array. Okay, and uh, so in Lisp, array is actually called, for example, in Emac Lisp, array is actually called vector. So different languages you have different jargons. They use the same jargon but mean different things, and even the actual things in these languages are not the same. When we are typically when programmer when programming textbooks or tutorials speak of array, what they mean is they typically mean the array data structure, as in C languages array, the data structure. Okay, so let's go to this article, array data structure. Let's see if they explain why how array random has constant random access time. So it says in computer science, an array data structure, or simply an array, is a data structure consisting of a collection of elements, each identified by at least one array index or key. Okay, an array is stored such that the position of each element can be computed from its index tuple by a mathematical formula. Okay, the simplest type of data structure is linear array, also called one-dimensional array. Uh, okay, it gets complex. So it says an array is stored such that the position of each element can be computed from its index tuple by a mathematical formula. Well, this is a bad definition. The memory address of the first element of an array is called first address or foundation address. Okay, it's this gets complicated because it's getting into kind of implementation. But let's see. Yeah, it's kind of gets complicated, but actually it is rather very complicated to actually define, to give a definition of what an array is. But anyway, you can see here they show the so-called algorithmic complexity about array access, which means how fast the time properties of getting elements or setting elements, comparison with other data structures, linked list array, dynamic array, okay, balanced tree, okay, so on. Anyway, yeah, the Wikipedia article is getting complicated, but okay, but let me just tell you why then. Let me just tell you why accessing array is actually constant time. Well, the real reason is because electronic circuits. It's just so happens. Okay, it so happens array um, in modern CPU. Okay, again, remember computer programming languages and algorithms, source code, programming language, and machine, the machine it operates on are tied together. So when we talk about array, we are talking about today's CPUs. So array in almost all programming languages today, uh, they are implemented. It just so happens that the CPU they are the way it's done is by a memory chip and the electronic circuit, and it so happens that when you access an array, the CPU instructions, it simply put, it's just parallel electronic circuits. you know so it's kind of like parallel computing. Like in a circuit you have you in a you have all these wires going in, and the wires are wired in such a way that they are not like checking one element at a time. Rather it's like all circuit go in at one time and come out like eight of them, 8 bits or 16 bits or 32 bits at one time, and they come out. And that is why array access random, it has constant access time. Okay, that is it. So so this is very curious. This is very interesting because this is not, you know so what I'm saying is that this array access time, it has nothing to do with mathematical properties of algorithms at all. And because we don't think of it that way, because normally, for example, when you program in Python, Java, Ruby, or whatever, for example, if you are doing a loop, you go through each element and you talk about algorithmic complexity, how fast is this function or a loop, or how much memory it takes. you analyze it, because each statement you make, x equals to something, you know, it's a step. So you have to measure how many steps you are taking. That's how you measure, the algorithmic complexity of an algorithm or function. But when it comes to array, this is interesting because you have array 99, but however, it's like it's instantaneous. Like you don't have to jump 99 steps. It's actually just one step somehow. But however, for a list, um, for a list, for example, if you have a list here, then the story is entirely different. It's like suddenly you have to jump 99 steps. But meanwhile, there, the code, for example, my array, for example, the code is entirely different. My array, for example, in whatever language is this, let's say 1 2 3. Okay, let's say gen uh, okay, so here we have, you see, we can generate an array by this syntax, or we can generate a list by this syntax. Different language has different functions to generate array or list. So this is what we are doing. We see this, and it looks almost exactly similar. But however, so what I'm saying is that you do not see the algorithmic steps in the code. It's not apparent. But suddenly, all this code looks similar. It's not like when you have a list, you actually have a loop. You don't see it here. But however, when it comes to this part, suddenly they are entirely different. The algorithmic properties are entirely different. So that's what I'm saying about this thing, about this the strangeness about this non-apparentness of algorithmic complexity. Okay, that's it for that. Maybe that's it for today, depending on how you guys doing. So Isaac and George, 5 people. So guys, say something. So let's go back. Let's see what we want to talk about. This maybe other interesting things. Let's see. Keyboard review gallery. What is this? Oh, PC keyboard reviews. Okay. Let's go to programming blog. So today I just actually operators control. So array access constant time. Yeah. So this is a very interesting question to me. It's something I. Let's see if there's something I want to say about this. Yeah. So anyway, that is the issue I want to say. Like if you go online, let's say, all the answers online is basically wrong, because I've been trying to understand this for 10 years. For example, let's say why array has constant time. Let's say you type that and see what others say. Why does accessing an array element takes constant time? So this is on Quora. Now Quora is not really a good quality. So here another question on Stack Overflow. Why does accessing an element in array takes constant time? Okay, so let's check some of the answers. I bet they are just they are just so this guy on Quora says, before I answer it completely, know that array, linked list, map, set, act, everything that you program creates would be in RAM during your program execution. That means RAM part is ruled out. What? Okay, then array, the fundamental concept here is that the elements of an array are stored in contiguous memory location. Okay, it is this guarantee that makes array access constant time. Yeah, so he's talking about memory. Yeah, in general, if I know the base address of array, for example, A0, I would get the address of an arbitrary element in array AI by simply doing address of plus size. You see, uh, yeah, okay, that's basically what he's saying. So he's saying it's because uh, it is stored in contiguous memory location, but that doesn't explain nothing. You see, that doesn't explain. So what do you mean contiguous memory? So the real answer is that this memory address, because of the circuit and electronics, because the way computer are designed, you have 16 bits architecture or 32 bits architecture. They operate something like that. It's because the parallel nature of the electronic circuit. Okay, okay. So let's look at the Stack Overflow answer. Let's see what they say. So why does accessing an element in an array takes constant time? Answer: just to be complete, what structure is accessed in linear time? Okay, linked list structure is accessed in linear time. Okay, uh, an array is more similar to a hard disk. Every point is accessible in constant time. This is the reason the RAM of a computer is called RAM, random access memory. You can go to any location if you know its address without traversing all the memory. Okay, yeah, so it again, he just says because it's in RAM, random access memory, the memory chip. Yeah, but it doesn't say why it is that way. So yeah, so anyway, so the first time I actually found the great answer to this question is this guy. This guy by Ying Wang. He wrote a blog about it. Why array, why is indexing faster than binary search? You know, so he talked about the issue that answered, that really answered my question. I had this question for like 10 years. And in his blog, he actually showed you the circuit design, you know, because in the past when because if you think of array, if you think array like the code we have before, uh, if you look at them as if you try to answer the question by thinking that it's some sort of mathematical property, it's because math, because algorithms, because algorithmic complexity, because of math, that is why array access time is constant. If you try to think of that way, that is wrong. You see, so that is why it's a great puzzle. The real answer is that it has nothing to do with math. In a sense, it has nothing to do with math. Rather, it's just because it so happens that the memory circuit is implemented in parallel. That is why. Hi, Aldo. Good morning. So I think that's it about this array access. Yeah, so this is the first time I understand this is, I saw a clear explanation is via this guy's blog. By the way, this guy Ying Wang Ying, he is a very controversial guy, and he's very well known in China. One of the most well known blogger, and and he constantly write blogs with opinions that are completely controversial. Like, and many of his blogs are silly. Oh, so Isaac, you also write Chinese. Isaac. Wait, Isaac, you are in Los Angeles, right? And Isaac, you are American-born Chinese, right? So you learn to write Chinese. So okay, that's about array. Okay, let's go. Let's go. So today I actually kind of reorganized some of these bunch of articles on my website. So you have these articles on programming language design issues, the ontology of programming language, a class of computer languages, math languages, and you have the other topic, a bunch of articles about programming idioms and style. Uh, and another bunch of articles under the grouped title of programming languages and their machines. So these articles are related to programming or programming language issues that are actually has to do with the machine it operates on. Uh, and today's example about array access is one of the article. It has to do with the CPU. Uh, so anyway, so if you are interested, read this article, programming language and its machine. So I don't know much about CPU. I was never a systems programmer. Programmers means those people who write hardware firmware. Who write programs that's embedded on the hardware chips, or those people who write drivers, for mouse, keyboard, or who write Linux, operating systems. Those kind of programming you call system programming, and you use languages like C, sometimes C++, or sometimes Golang to program those kind of thing, or assembly languages sometimes. So this, systems programming usually means that your program must run very fast, extremely fast. For example, if you write the operating system, because everything else depends on top of it. It must be very fast, and also it is very low level. So you deal with the machine itself. The memory locations. You have to do that kind of thing. So that's kind of system programming. That's what so-called systems programming or low-level programming. And I don't have any experience in that, including assembly language. So you have machine language, assembly language, and then you have C, and so on. So I never have much experience about that, and I don't know much about that. But in the past few years, 5 years, I tried to learn something about it, and that's tremendous. I learned a lot. So check out this article, programming language and its machine. You'll learn, if you don't know about systems programming, you might learn a lot thing, something from my perspective. My experience is mostly from mathematics. Nothing with or theoretical computer science or math. That's my interest and my background. Well, my experience is mostly web applications, web programming. I was working for backend servers and websites. But my interest is mostly uh, theoretical computer science and algorithms, mathematics, mostly mathematics. So the way I look at things, so I don't have much experience with systems programming, but it's very interesting though. So you check out this article, you'll see my perspective on it. There's a lot about it, about CPU design, and it's an entire field. And it's like it's not just it's a entire field but it's actually like so fundamental because all the programs, the machines we run, they need a CPU. And these corporations, Intel, AMD, IBM, they design the chips. they the machine controls. I mean, it's not like, from my point of view, from high level point of view, math point of view, I'm always interested in algorithms or elegance of programming languages, language design, programming language design, uh, functional programming versus object oriented programming, different styles, which one is more, you can analyze it, math, or lambda calculus, or but however, I realized that many of the programming languages, these high level programming language issues, the CPU actually dictates what your language can be. So this ties to what we've talked about today about, programming language, about a machine. First of all, you need the hardware, a machine, a specific machine. Different machines, you need a machine, then you have a programming language, then you have the algorithms or instructions, the actual source code or recipe. A machine, programming language, then the recipe or source code or algorithms. These three things makes up the whole programming, and these three things are intimately tied together. I mean, so forget about the general idea, concept of algorithms, like almost that it doesn't exist. Even if you say 1 plus 2, when we say 1 plus 2, we think obviously the answer is 3. There is no machine involved, but actually there is, because when you say 1 plus 3, the machine is actually a mathematical model. Then you go into set theory, the foundation of math. There is basically you are working with a abstract machine, the set theory. You have the concept of one, then you have a concept of two, then you have the concept of addition. In set theory terms, which means take the next elements, and anyway, so that's math point. So when, even if you say 1 plus 2, you are working, that's a instruction, that's a algorithm, and you write it down in math notation, which is the programming language, 1 plus 2. Then the machine is actually set theory, that's math. So but normally we don't think of it, we don't think of it as doing a machine. We just say 1 plus 2, or print 5, but actually it's important to always have a machine, to think of a machine. So the machine and the programming language and the algorithm or source code is actually, they are intimately tied together. And mostly you cannot just design, I'm going to design my own programming language that's better than Haskell. You cannot do that. I mean, because when you do that, actually the machine actually dictates what programming language you can have, or what kind of programming languages you can have, or what kind of programming languages, or what actually it controls. The machine is the fundamental thing. That's what I learned. The machine, the CPU architecture. Although we can generalize a lot of it, but actually it is the machine that controls what programming languages you can have, what kind of design you can have, because then from your programming language it controls what kind of problems it can solve. So the CPU is actually fundamental. And so let me talk about what different kind of machines. So machines, we can have calculus, we can have, different type of CPU, Intel i5, or Xeon architecture or ARMS processor, and all different sort of machines. Then we have Turing machine, we have state machines, we have, cellular automata, all different machines. And we can also have, today we have quantum computer. That is a machine, quantum computer. And, like I said before, what machines you have governs what kind of programming language you have, and in turn it governs what kind of algorithms or the recipes, or the problems you actually solve with it. So when you have a quantum machine, you don't program it with Python. you know you know you don't program it with Python or Lisp or whatever. You have a specific programming language for quantum computers. Quantum computers is a machine, and we also have, biological based computers like DNA machines. DNA machines. That's, you throw a bunch of molecules. It's amazing. You just throw a bunch of molecules. Think of molecules as some sort of marbles. You throw, billions of them in a box, and they automatically, you know arrange themselves, bind, one to each other, and that's the answer. They do it automatically by itself, billions upon billions of them. That's what DNA computing is about. And so that's your machine. So in this case, you don't program it with Python. You have special language for it. So anyway, I think that's about what I'm saying about the machines and languages. Okay, so let's see what we let's look at the comment. AZ, hello AZ. AZ says you are pregnant. Are you serious? AZ, so you are a female. Uh, so Sean says, Sean Panzera, good morning. Gonna check that out. Systems are mysteries to me. So, and Sean says, seems like the machines is like a box. It has a size, you can overfill it. Some boxes are larger than others. The size of box dictates its contents. Yeah, you can say that. But it's more than size though, because, you know, we have to, I mean, as far as analogy goes, because almost all these machines we've talked about, they do have a size too. Like CPU can have, different number of pins, or an abacus can have, different number of columns. So all these machines do have a size as part of their aspect or property, but they differ in so many other ways. So anyway, I think that's about it. So guys, so AZ, this AZ girl, AZ woman. So you are a girl, you are pregnant. How did you find me? How did you find my channel? That's interesting because usually my channel are followed by just nerds. So are you also a programmer, or? So yeah, so uh that's the thing I want to talk about. So you go to my website, that's under Semantic Noodle, and yeah, I did some organization. Like I wrote these articles in 20 years. I wrote them in a span of 20 years. Yeah, since 2000. Uh, and I have so many articles, and usually they are chaotic. They are, you know, it takes tremendous time to actually group them. Like, this set of essays are related to this category of topic. You have to reread them. It's really tedious. And usually, and also another interesting thing is that when you write a blog, sometimes when you write a blog, they don't fit. A blog article, they don't fit into particular category. Like they talk about something here, but they also talk about some other things over there in that category. So, part of it is a tutorial about how, for example, how do you create an array. Then part of it talk about, you know, something about the design of a programming language. So yeah, array. I mean, blogs. The nature of blogs is very different from tutorial, and also very different from an essay actually. So because when you have an essay, usually it's focused on particular topic. When you write a blog is like the is a bottom is a it's very loose. You can be anything. It can be what you ate today, like you know well, I mean, yeah, and also different, like the style can be very sloppy. It can be a dialogue. It can be a chat between you and your friend about any programming topic. So blog is very loose. Um, it's hard to. I mean, even if you wrote blogs for 20 years, and usually blogs are ephemeral, like they are write once and throw away. Like the next day, they become less important. In a month, they become irrelevant. Or sometimes after a year, they become useless. That's the nature of blogs. So it's different from tutorial. So if you are a blogger, if you guys blog, you might want to pay attention when about these, because usually if you just write blogs as you go, usually the value of a blog article, they go away, they disappear quickly. Especially like Twitter or social networks, Facebook. Those are what you call micro blogs. Their value usually go away within 1 hour. You post something on Twitter, within 1 hour, nobody ever read it. Or after one day. Some of your friends might, maybe they'll check it, but usually like within 10 minutes, the value is gone. Nobody will see it. That's one of the sad thing about social networks and blogging, and that is exactly how Twitter and Facebook. That is exactly their intention as well, because they want to make money, and they want to people to keep posting. So they want to make sure that they want to make they want to make you to keep posting. So they designed that way, so any post has no value after an hour or after a day, something like that. You want to repeat whatever you say. Okay, no comments then. That's it for today then. Thank you guys for watching. I'll see you guys next time.